So let's go to class notes. Okay, so this is how you would typically do things, right? Just back to my notes. Where's my notes? Oops. Oop. Did I just cancel Zoom? Oh, sorry. My bad. Now, okay, I'm just gonna keep talking while he fixes. Yeah. So like I said before the break, right? You are going to be defining your own function. Yeah, defining your own function.
I think Akshan,
Yeah,
it's closed already, but you can continue like now.
so it's okay.
I think it's okay from here. I think I will.
Okay. So this is like a second half.
Yeah, it's
okay. So apparently we didn't record anything. Okay, let me just say this again, just for the video. Welcome to the second half of today's lecture, right? So the first half, we did this thing where we talk about primitives, the bracket, the comma, the semicolon, and all that stuff. Now we're going to use a function, okay? A function, the most primitive form of function is a prompt, a function that doesn't have any argument, like now. What's now? What's tomorrow? When's tomorrow? And then you have function. Function in Mathematica, as in many functional programming language, expects certain number of arguments. In addition to which, there's a flexibility for you to enter optional argument. So the example that we can use again here is the plotting function, right? So this plot, it expects a few things. So let's go back to a simpler version, right? So in this case, it's expect two things: what to plot and the range of value from which to plot, right? In this case, I'm not going to plot one thing. I'm going to plot two things: sine x and sine 2x. Maybe I make sine 2x a bit smaller, so at 0.5 here, okay? And the range is from here to here. See? Now, what I can do, let's make it cosine so it looks different. Okay, so that's my function, right? Now the optional would be if I add to say something like image size small, something like that. Okay, fine. And I want to have a little bit of filling to the axis. Okay, something like that. Fine. Okay, so let's go. Let's move on. Let's move on. Oops. Okay. Now, I'll give you an example, okay, of what things can look like. And this looks a little bit complicated, but actually it's not. Okay, watch this. Look from the inside out. Okay, inside out. This is a function called table. Okay, so if you type in table, right? If you type in table and you click on it and you type F1, it's going to take you to the help page that say table. Table is a list constructor. Simple as that. Except instead of, again, a list is just a list of things, right? But a table is a list of things that follows certain pattern. Okay, let me put in the bracket for those of you who've done Python programming. It's kind of similar to well, I was going to say list comprehension, but okay. Basically, you want to create a list of things by following certain rule or pattern. Okay, so if I want to say create a list of numbers that is expressed in the form of integer I square or something like that. Okay, so it's kind of like it's not arbitrary. Okay, now a good example would be for me to actually show you what it is. Okay, let me show you what it is. Sorry, not show you what it is. Show you an actual example. See that? I'm creating a table. a table of what? Now, this is a little bit like plot where you expect two things. Okay. It's giving a table of n factorial divided by m factorial, n minus m factorial. Anybody remember what that is or recall that from high school? It gives you how many ways can I choose m object from n spots. Okay, so there are 20 students, right? I have 3 shares. How many ways can I fill the 3 seats with 20 students? That's equal to 20 factorial divided by 3 factorial times 17 factorial. Okay, now I'm not going to spend time talking about that. If you know, you know. If you don't, you can ask me later how that formula came about. But anyway, I don't want this for 20 and 3. I don't want this for 20 and 3. I want this for a range of numbers. So my table here say I'm going to pick m from 0 to n. Why? Because if n is the number of students, can I fill more than 20? No, I can't fill more than 20, right? Can I fill 0? Yes. Can I fill 1? Yes. Can I fill 2? Yes. Up to 20. So if I have n students, I can fill m. M can be anything from 0 to n. And then n can go from 0 to 6. Then I make another table rapid. So it's a table of table. And what's a table of table, guys? It's like a matrix, right? On top of that, I'm not happy. I'm going to make a grid. A grid is like a grid is literally a grid, okay? And I put frame through, that means, you know, frame all. Let's see what that looks like. Yeah, well, tell you what, let me do this. Let me just forget about frame through. Let me do this. Okay, frame all. Okay. Now, what it doesn't really matter. Okay. The point is that this grid thing, that's not the main reason. In fact, maybe this is a distraction. I just do this. Let's do this. Let's take the grid out. So I didn't put in the grid, and I put here. I take the frame out. Okay, just the table itself. Okay. Right. So it's going to have 6 rows, but the number of columns is not fixed because if I have 1 student, there's only one way I can pick 1 chair, right? That sort of thing. So this is, anybody? Pascal triangle, right? You did this in high school. I'm pretty sure you did this in high school because I did this in high school. Okay. Now I can put in table form. I can put in matrix form, but maybe table form is nicer. Okay. Right. So from, what's this number? 6. What's that? That is, I have 6 students, and I have 1 chair, 1 or 2. Yeah, 1 or 2 chair, 2 chair. Okay, something like that. So this is basically a table of things. Okay, so table is well, I already told you that tabular data is the most ubiquitous way of doing things, right? In programming language, in any language, Python, no exception. Python, R, C, Wolfram Mathematica, a list constructor is going to be your best friend. Okay, you're going to work with table all the time. Okay, because what it does, it allows you to do repeated computation and list them. Okay. Now, maybe that's a little bit not very clear. So I'll give you another example. So from table Okay, let's say I, type in I, okay, shift, and then this kind of arrow, where's your arrow? Shift arrow, sorry, control arrow, okay. Now let's do this. Let's make a table of 2 to the power. Okay, 2, okay, type in 2, sorry, I changed my mind. 2, control hat, where's hat? So that's 2 to the power A. Okay. Now it's not finished. A from 7 to 11. Okay. So that's going to give you 2 to the 7, 2 to the 8, 2 to the 9, 2 to the 10. Now notice this is comma, not semicolon. Semicolon is only used for that that element thing. Yeah. Right. Okay. So this is it. Now, if I do this, if I did this, and instead of say 2, I do something like B, and I put bracket around it, and I say table of this, comma, B from 2 to 5. What do you think is going to happen? It's going to give you this, right? Because the inner bracket gives you the row. So the inner bracket, okay, look at this. This bracket, when B is equal to 2, that's 2 to the 7 to 2 to the 11. That's this guy. When B is equal to 3, that's 3 to the 7, 3 to the 8, 3 to the 9, 3 to the 10, 3 to the 11. When B is equal to 4, 4 to the 7, 4 to 8, 9, 10, 11. When B is equal to 5, that's 5 to the 7, 5 to the 8, 5 to the 9, 5 to the 10, 5 to the 11. Okay. In other words, the reason this is so useful is because I think when you were in 9th grade, if you took any kind of computer programming course at all, you might have taken like C, in which case you had to do a lot of for loop. Okay. Table is a very economical way of doing for loop. Okay. So instead of for B equal to 2 to 5, for A is equal to 7 to 11, do this. It just sort of like does this in one shot. Okay. And this is very popular. And in Python language, it's called list comprehension. I'm not sure what it's called in R. Okay. But it's a similar kind of thing. It's a very convenient way of creating pattern series of objects, basically. Now, why would this matter? Well, we'll see. Okay. So don't worry about how this would become data analytics later. Okay. This is all about learning how to manipulate. Okay. So this is your function. This is very simple. All right. This is your function. So this is an example. Now, let me give you a lot of built-in function. So this is so a function here. I'm just going to run through example. I can give you this later if you want. Exponential of 1.23. So that's that number. Length of this. Length is like how long it is. It's 3. You can see that. Okay. Now RGB. I don't know what it is because I haven't assigned it. Probably earlier page. But date object is now. Okay. Date object. It's the same thing because if I say tomorrow. Okay. Right. So this is a problem. This is a date object. Fine. I do this a lot. Set directory equal to current directory. So wherever this file is saved, in your computer, if you save this in my document, okay, and you ask, what is this? It's going to say that. Okay. Now, in this case, I'm inside desktop autumn, blah, 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 teaching material. Fine. Okay. Now, this, I can set directory equal to this. When I set directory equal to where the file is, what it does is that when I import file or export file, it's going to go there. Okay, I use that a lot. So anyway, factorial again. Yeah. Remember I told you everything is a function. Well, factorial, you get 7 with the exclamation mark. Well, that's a shorthand for a factorial function. This, by the way, is very interesting. This is what ChatGPT would give you. Gamma is an approximation. Well, it's not an approximation. It's actually deeper than that. But for an integer, gamma is sort of like an approximation. Okay, not. So all kind of stuff, exponential, log. So these are all built-in function. Okay, so built-in function. And this is what I was telling you earlier. Instead of if I take 123, take exponential and take log, what are you going to get? Well, exponential and log is the same. It's an inverse of one another, right? So it's going to get the original. Okay. So now I want you to type this in your thing. Okay. Because this is exactly what you would see. Now, I haven't defined what f, g, and h is, but I say that f of x, g of f of x, h of g of f of x, is it equal to h at g at f at x? Yes. Is it the same thing as x slash, okay? Yes. Okay, now I put bracket around this so that you know it's 1 unit. So if I did this, it's the same thing, okay? It gives you this even though you haven't defined what f of g or h is, okay? So basically, the left-hand side, the leftmost is the proper way of writing, right, guys? It's a proper way of writing function. You take x, you put in f of x. You take the result of f of x, you put in g, you get g of f of x. You get the result of that, you put in the function h, you get h of g of f of x. But because when you write something like this, you get a lot of horrendous bracket at the end. Sometimes it's not pretty. Okay, so ignore this because you don't really need to know this. But in my code, if some of the thing that I share would be my code, I would tend to write h at g at f at x. Okay, so you don't get confused. Okay, it's a shorthand. It's a shorthand. Or sometimes you just see x, then do f to it, then do g to it, then do h to it. This is just shorthand. When I started learning the new language, all this shorthand really annoys me a lot because it looks like it makes things very difficult to read. But once you get used to it, it becomes easy. It's like a shortcut, you know. You like to use shortcut because not because it's pretty, but because it's. And in fact, a plus b is a shortcut for plus, right? If you're gonna be, you know, sort of like strict about it, every time you want to add number a and b, you have to call a function called plus. Okay? Right? So that actually is a shorthand. You can think, okay? So everything is a function. Okay. Now, here's an interesting thing. This is where you start to get into calculus. Okay? So what's x power x of 3? Well, I can do this, right? Power of x of 3 is equal to, well, x, right? So I can write this actually. X, oops. X, control hat, where's my hat? 3, okay? It's the same thing, it's the same thing, okay? So in fact, let me show you. Now, I don't know why I wrote this out, okay? What do you think this D stands for? Anybody? Derivative. So this is derivative of x3 with respect to x. Okay. Now, what's the opposite of derivative? Well, it's integral, right? Right? Okay. Think about how cool this is. Just this here, okay, it looks simple, right? You can do it because it's simple, but you can do this for any kind of function. This is one thing that definitely cannot be done with Python or R or any language. There are about 2 or 3 software or language in the world that can do this kind of analytical computation. In other words, it understands symbolically what taking derivative means. Okay. In fact, I can take x from three to four, right? Okay. Now, what else can I do, by the way? Well, how about x to the minus 3? Okay. Now, I can do this, by the way. Instead of integrating from 2 to 3, I can integrate from 2 to infinity. Okay. This is because it's not doing it numerically, it's doing symbolically. I think there are about 2 or 3 languages in the world that I only know one. The other one is, I think, Julia or something. Okay, it's even more esoteric. Okay. Yeah, you definitely can't do this in R or Python or any language. Okay, you can do it numerically. It's going to give you approximation. Yeah, it's going to give you something that's close to 0.125. But this is exact value, guys. Now, you can do this in your head because you know what this is, right? But imagine something a lot more complicated. Okay, complicated. Yeah, so for example, so integrate all kind of stuff. By the way, this is another way of writing. You can go to palette here, and go to special math assistant, and you can write it in mathematical form. And in my own note, to be fair, I don't write this. I think it looks ugly. Yeah, this looks ugly. So when in my note, I would do this. In my own note, I would do this. Yeah, it's the same thing. Same thing, right? Except it's prettier. So yeah, just to show you that is it the same thing? Yes, it is the same thing, except the left-hand side looks ugly. The right-hand side is pretty. Okay. So when given a choice between ugly and pretty, I choose pretty. Now, we will get soon enough, but just to show you how how powerful this is. 10 years ago, I'm talking about R. 10 years ago, R has the largest library in terms of probability distribution in the world, R. But as of, I think, 2018, Mathematica has larger library. So even for probability, this one, normal distribution, anybody has it. But, all kind of weird distribution, cat distribution, popular fun, weird distribution, okay? Only that R bind that I was showing you during the break, that one that and it's not a standard built-in. Somebody wrote it as a code, and I and makes it share. So anyway, here's the deal. I can generate random variable from normal distribution. So this is how you call a function. Now, I can't. Okay, so a table, if I want a number between table of I from 5 to 9, what's going to happen, guys? It's a simple pattern, right? I going from 5 to 9 is going to give you 5, 6, 7, 8, 9. Again, common sense say because you use this a lot, at some point, the developer is going to write a shorthand for it, and that function is called range. So when you do range function, it is exactly the same thing, okay? So what it means is that if you can memorize 20 built-in function, you can do everything. But the code is going to look ugly, right? So if I memorize just the word table, I can do it. But if I also remember, wait a minute, there's a shorthand for it called range, my code is going to look prettier, okay? So this is a trade-off. It happens with every language. And the more professional you are, instead of memorizing 20, you memorize 50, okay? I personally am very terrible. So every time I think I would do this, I say, wait a minute, this thing is used so often, there must be an easy way of writing table from 5 to 9. What is it called? I just go to internet and I'll ask. And somebody say, oh, that's simple. It's called range. Yeah. So this table array is, okay. Now, it's important that Raise your hand again for those who have done Python. Okay, well, this is just a dictionary. Okay, association is Mathematica's word for dictionary. How do you create a dictionary? It's like this. And this is the last primitive that you need to know for today. It's a funny bracket that looks like a left hand. It is. Okay, and this is association. Yeah, I make this. Okay. Now, association is like a list, but it's a list of referral. It's a list of lookup table. So to make it a special notation, the shorthand for it is this. So this is a dict. Okay, in Python, this is called DICT. Okay. Now, the word red points to this function. And this function is a built-in RGB color. R is equal to red. So that's it. So now, next time I write this, and I put in red, I'm going to get red. That's it. So it's a dictionary, okay? The left-hand side is called the keys. The right-hand side is called the value. So the left-hand, so these are the keys are the red, green, and blue. Those are the text. So this is all you need to know, okay? Association. Now, how do you make an association? Sometimes instead of having this arrow here, it looks a little bit, difficult to key one by one. Sometimes I just import a whole list of 1,000 number and a whole student ID. So let's say I have a file of 100 student, right? ID, and I have a file of 100 student grade. Instead of going one by one, I just say, let's make an association and thread them into a rule. So this is called association thread. Now, some of this is used so much, association thread appear probably 100 times in my code every day, okay? So that's basically creating an association between the word red and this color. So that's what it does, okay? That's what it does. Okay. So all this thing is association. Now, I'm going to say one thing that some of you may find a little bit abstract. A function is a mathematical way of implementing association. A function and association is virtually the same thing. Association is a computer science concept. Give me the word red, I give you color red, right? But what's a mathematical function? Think of it, guys. Let's say the function is square, right? It's the same thing as association between number 2 and number 4, number 3 and number 9, number 7 and number 49, right? So a function is the same thing as a lookup table. Now, some of your algebra teacher may have said this, and you probably thought they didn't mean anything. A function is exactly what a lookup table is. So if you know what a lookup table is, you know what a function is. Okay, but I'm just gonna not gonna pay too much attention on this. Right now, okay, there's a lot of built-in functions that are very useful in data science. One of them is count. Okay, so if I give you a list, say this is a list, right? Now you can count this yourself. How many 1, how many 2, how many 7, how many 3, right? But imagine that this is 1,000 number. The function counts gives you this thing. It gives you association from 1 to 5, 2 to 7. So in other words, it gives you association between the content and how often it appears. So if I put this, now this is obvious, right? If you see this, I ask you how many times does 1 appear? You can say, well, it appears 5 times. But if this is a million, you'll be out of luck, right? So that's what this function is so useful. And again, it's one of those things that you'll see 100 times in a data science project. Okay. So how many times does 1 appear? 5. How many times does 2 appear? 7. Okay. So this counts function happens a lot, used a lot. So I'm listing this. Okay. Thread is another thing, but we can come back to it. Some of this, if I give you right now, you may not think it make any sense until you get to use it. Now, here's a fun thing. I'm going to skip this. I'm going to come back to it. Let's go to user-defined function. Okay. Let's say, okay, you know how to do this, right? Exponential A. Okay. And you know how to say 1 divided by B, right? What if you want to do this? 1 divided by 1 plus exponential minus A. Okay. Let's say you want to do this. Okay. You want to do this. And this function doesn't exist. Okay. Now let's make it more interesting. Let's make it X and A, something like that. Okay, what is this function? This is a function that you define yourself. Okay, so how would you define it? Again, this is a built-in, division is a built-in, addition is a built-in, exponential is a built-in, but all this is not built-in. Now, how many things does it take to specify this function? 2 things, right? You need to put in X, you put in an A. So you write this way. My funny function takes A underscore X underscore bracket colon equal. Okay, now let me write that down first. Don't worry. Okay. This is the standard way of defining a user-defined function. You write whatever you want to do on the right-hand side. Okay, you name it. I name it my funny function. Right now it's blue because it hasn't been defined. Okay, it hasn't been defined, so it's just blue. My function expects 2 things. One, I'm going to call A. Now, this underscore say is a notation for saying it's a variable. I'm expecting to see A. I'm expecting to see X. And what am I going to do with A? What am I going to do with X? Notice the color match, guys. Okay, let me show you this. Okay, before I did this, look, X is a blue thing, right? It doesn't know what that is. But if I put it here, X underscore, it knows that the right-hand side is to be supplied. So this underscore means to be supplied. Okay? I'm defining a function to be supplied with A, to be supplied with X. Once I'm supplied with parameter or argument A and X, I'm going to put A on top, divide by 1 plus exponential X. Okay? Now, if I shift enter right now, the only thing that's going to change is that the blue is going to become black. Because now it knows what it is. Okay? So this is like going to the deli and say, this is my usual. You know how to divide, you know how to add, you know how to take exponential. My special recipe for a sandwich is to take exponential, add 1, put on the bottom, and multiply by A. That's my special sandwich. Okay? And my special sandwich is called my function A. So now, when I go my function A, look, see? It becomes autocorrect because the system knows I've defined it's like it's on a register list. So it's now a valid function. So if I tap, it actually autocorrect for you. Okay, so I put in 3 and 4. There it is, right? 3 divided by 1 to the e to the minus 4. Okay. Now that it's actually a function by itself, can I plot it? Yes. So let's say let's keep the first thing 3, and let's make the last one my funny function, right? Let's make the first thing 3 and X. Okay. Oops. And I'm going to plot this guy. Plot this guy. Plot this guy from X. Let's say from minus 10 to 10, maybe. Minus 10 to 20, right? There it is. That's a function, right? That's a function. Now, okay. So this is how you define a function. Now, notice that this is a function of two variables, right? So actually, you would rather see what happened when this thing changes. Well, so how about this? I make A, and let A change as well. Okay, let's A change as well. A from -1 to +2 to +1 to 2. Okay. Now it becomes a function of two variables. So the plot will be a surface. So I use the function plot 3D. Okay. Now, if you use matplotlib in Python, it's going to take you 15 lines just to get that. So what does this do, guys? See? A from -1 to +2. X from -10 to 20. Right? Okay. So this is how you put function inside a function and do things to it. Most of the time, this is what happened. The first kind of function will be the function that take data and sort of like do some kind of analytics, some kind of fitting. And then later on toward the application, you're going to take the result and you're going to apply to the visualization function. Okay. In fact, as a data scientist, I can tell you what worked, what happened. You download the data, you use this kind of function, this kind of visualization to visualize the data, get an idea of the relationship, do the analysis on it with proper mathematics, statistics, machine learning, AI tools, whatever. Once you get the result, you do the visualization again. So visualization is very powerful. You visualize the raw data, right? You cook the raw data into insights, and then you visualize the insights. Okay? This is how data scientist professional do things. I never jump in with just the data and the tools. I take the data, I visualize the data as much as I can. I form hypotheses, I create experiment, I run things, I get some result. Once I get to the result, I don't show my client just numbers. I visualize the result in this kind of thing. And the way I would tell my client is, you know what? Let's say this is your profit function. You make a lot of money here. You lose a lot of money here. So let's go over here. That sort of thing. Okay. I never give just tables of number to my clients. Never. Okay. And I use visualization for myself to guide my model building process. So in your project, you will quote unquote, remember the learning outcome? You put yourself in the shoes of what a professional data scientist does. Well, in your project, that's what you should be doing. You'll be working with the data set, visualize, get some idea of what you should do with this data set, apply some tools to it, machine learning, we'll learn about that, some kind of maybe AI algorithm, maybe some kind of clustering, maybe some kind of machine learning routine, get some result. Once you get some result, you have to check if you make a lot of error, good prediction, forecast, bad forecast, and so forth. Visualize all that. Visualize the result, visualize the error. That's how you publish. Well, I don't mean publish. That's how you display your result. Okay. So visualization is extremely powerful thing. Okay. I do all the mathematics behind the scene, but when I show the result, it's always pictures. It's always pictures. I rarely ever show any equations. Okay. But when I work with the client that has an in-house technical team, that mathematics is how I communicate with their technical guys. But the guys who pay for the project, I always show this picture. Okay. Yeah. So this would be one thing. Now, before we finish, I just want to show you that this is not it. This is not it. There's something else called, well, what's the name of my book that I'm writing? Interactive, right? Well, you can say that this is interactive. Okay, you can do this. This is interactive, but that's not the real interaction. Interaction I want to do is something like this. Okay, let me show you. So something like, I'm just going to make this up. Okay, this doesn't mean anything. So let's call this M. Call this guy M. M. And I'm going to say M from, I don't know, 2 to minus 10, minus 10 to 10. I don't know. Just making this up. Yeah, so it's actually another parameter. It's another parameter. Except I'm going to use it for different function. This function is called manipulate. Yeah, and so this is my function, and plot x1, x2, x3 plus 3D. Okay, and is that right? Hold on, let me put my glasses on. Okay. For some reason, where's my comma? I'm missing a comma. Oh, that's it. So now, well, hold on. Let me put this on the bottom. This is optional. Control placement. Let's make it the bottom. Okay, now. So what makes it interactive, and this is how I sell my project, is that, let's say, I don't care, okay? Let's say you're trying to sell a design concept. You send this to your client say, oh, I like this, but I want to change the color. I want to change the shape. What most people do is to say, okay, fine, I'll take this back to my design team. I'll redraw the thing and I'll send you back the file, right? Now you're done. Now you can do this interactively. You can actually move this parameter. Okay. Now, this is just a silly example. I'm just making this up, right? So this is I'm moving a design here. So, but this is kind of interactive design, right? Right? Now, this doesn't mean anything to you. This function doesn't mean anything to me. But, you know, you can imagine you're designing a cup or something like that, whatever. You're designing you get my point. Okay? This is what I mean by interactive visualization. It's not just interactive in the sense that, you know, you can move this thing around, but it's interactive in the sense that you can control the parameter of your function. Okay? Now, when have I done this? Well, a good example would be this. When COVID came about, okay? By the way, COVID dynamics is well defined by partial differential equation. If I have a rate of infection, meaning that when people come together, there's like 30% of transmitting or something like that. Okay, that's the rate of infection. If I have an initial population size, I have all this statistic, I can predict how many people will be infected by the end of the month. Okay, so this is well defined. This is well defined. However, because it's a new disease, right? How do we know that the rate of infection is 0.3? Why not 0.4? Why not 0.5? If you're going to present this to people in the healthcare and you have a rough idea, but you don't have a fixed idea, right? Because this is a new disease. I don't know what the rate of infection is, but it's not going to be 90%. It's not going to be 0%. Let's say it's between 30 and 90%. What I'm going to do is put 30 to 90 as my button. And I can give this to the whatever policy maker and say, if the infection rate is 0.3, this is the rate of infection. By the end of the month, we're going to have 400,000. But if I move it up to 0.9, by the end of the month, it'll be 2.7 million. So the mathematics is precise. What's not necessarily precise is the coefficient, right? Now, this is the opposite way of doing statistic. When you do statistic, you have mathematical equation. You take the data, and then you estimate the coefficient. That's your job as statistician. And in fact, most of the time, that's what I do as well. But occasionally, there will be situation that's new, where you don't have a good set of statistics, data, to determine what the coefficient is. The way you make decision is to use this kind of interactive visualization. I don't know what coefficient of infection is, but let's say it's coronavirus. So you know from the past, coronavirus infection can be as low as 0.5, can be as high as 0.9. So I said, well, you know, it's kind of similar kind of disease, right? So let's see what happens when it's 0.5 up to 0.9. Okay. And instead of doing it as a table, I can literally do this. Okay. So interactive visualization is so powerful. Okay. It's so powerful. It's powerful before I build the machine learning model. It's powerful once I build the machine learning model and get the result, get the analytics and display. And it's also powerful in this kind of situation where you don't have a prediction model. You don't have, because you don't know what the coefficient is, but you're trying to do this kind of scenario analysis. What if the infection rate is 0.6? What if we're wrong? What if infection rate is 0.7? What is 0.8? What is 0.9? Do we have enough beds? Right? So this becomes like a simulation tool as well, quote unquote. Okay. So I don't want to go into what you would use this for, but I just want to today, all I want is for you to memorize or be familiar with the primitives, you know, the curly bracket, the square, the semicolon, the dot, the association. That's all I want. That's all I want. Okay. Now, what I would like to do, okay, normally what I would like to do is then take you into sort of beginning of data analysis with visualization, with like this. Remember I told you that you just take the data and you visualize, and then start to work with real data. Start to work with this thing called data set, which is a way of manipulating table. Okay, that should come in like about week 4 or 5. However, and when I do that, I want my guy who's very good with Python programming to come and teach you guys how to do this kind of what's called data frame. The reason that you would benefit is because, again, most of the time your data comes in table form. Right now, this matrix is a list of lists. You know, you don't know what the heading is. You don't know that 73 stand for temperature or my weight or my resting heartbeat. So you want to have this kind of heading, right? The name of the column, the name of the row, and the index, this sort of thing. So this kind of table data manipulation is done using what's called data set. But because some of you and a lot of you might benefit from learning Python as well, I want you to learn the concept of data set in Python as well. And in Python, it's called data frame. Okay, so I'm going to have my guy comes in, teach data set and data frame sort of side by side because it's the same concept, it's just different language. Okay, normally I would prefer that he comes in like maybe the 4th week or 5th week. Okay, unfortunately, unfortunately, next week I have to be in Beijing for another conference, not the one I'm presenting. This one I'm just there. Okay, but it's a prior commitment with Professor Warsack, so I can't get away from that either. So next week, I think I'll have him come in, substitute for me, and he's going to teach you data frame object. Okay, it's going to feel a little bit out of place because you haven't looked at, what are you going to do with the data set yet, but why are you manipulating? But just think of data frame as Excel without seeing the sheet. Yeah, think of it this way. Excel is very nice, right? You can go to the row, you can go to the column, you can see the name of the column, the title of the column. You can see that this column has number, this column has text. You can see all this, right? Right? Excel is very nice. Spreadsheet is very nice. Well, it's very nice, but it's limited. Imagine that you need 300,000 rows. Okay, so you have to have a programmatic way of manipulating the worksheet. You can't, drag and drop, highlight the first row to the last row when the last row is 300,000 row down. Okay, how do you do select? How do you do, say, combine this field with that? Okay, that is done through what's called data set in Mathematica, or in Python, it's called data frame. Okay, so that one, again, it's a little bit out of sequence perhaps, but that's what's going to happen to you guys next week. Now, next week, you will have 2 classes, okay? 2 proper classes. One is on Tuesday afternoon. The other one is on, what did I say? Thursday afternoon, okay? We'll send you the information on the room later. So it's going to be open lecture to the sense that other people will be free to attend. But, in the meantime, when you come, you give your name to the TA. So this will come as a real lecture. Again, this is also a little bit out of sequence because normally graph analytics, you would see that almost toward the end of the class before you start the project. Okay, but because of the traveling arrangement and all that, I apologize. Okay, but just be flexible. Okay, so next week you learn both 2 things that are normally further down the line. Okay, then I'll come back.